All right, in this video, we're going to find the area of one petal of the rose curve, define where r is equal to 3 cosine 3 theta. So it's just asking us, what is the area swept out by that polar curve of just one petal? So one of those. So there's a couple ways to do this one. We're going to use symmetry and just try to build that intuition to see what's going on here. So when I look at these, a lot of people just say, okay, when is r 0? That's great. I just don't fully see it. So I want to confirm that when theta is 0, that I get 3. And then I see as this sweeps out, as theta goes along, at some point, I think it's before I get to pi over 2, at some point it's going to be, the radius will be 0. And it looks like whatever this theta is. So first thing, I'm going to just plug in some points and just see what's going on. So if theta is 0, I get 3 cosine of 0 times 3. So 3 cosine of 0. Cosine of 0 is 1. So yeah, I get 3. So that means when the theta is 0, I get radius 3. Good. All right, so if I'm going to plug in on the unit circle that next radian, so pi over 6. This would be 3 cosine of 3 pi over 6, so pi over 2. Cosine of pi over 2 is 0 times 3 is 0. Okay, so this is telling me when theta is pi over 6, my radius is 0. So I'm sweeping this out from 0 to pi over 6, and I get half of one of those petals. So I'm going to start out by saying area is equal to 1/2 integral from alpha to beta of the radius squared. So in your calculator, it's going to be really important that you are careful with the parentheses. Put like 2 sets of parentheses and the squared on the outside. Okay, one way I could do this, I'm going to say the area is equal to 1/2 the integral from 0 to pi over 6, 3 cosine of 3 theta squared d theta, and whatever I get, that would just be this area right there, right? But if I double that, because this is symmetric, if I double that, it gives me the area of that whole petal, this side included, right? So that would be one way. That's not the first way that I saw it, so I'm not going to do it that way. I'm going to keep going. What I also notice is that since this is symmetric, this theta over here is got to be negative pi over 6. I think this is the way most people see these. So I'm going to say the area will be equal to 1/2 the integral from negative pi over 6 to pi over 6 of 3 cosine 3 theta squared d theta. And when I plug that in, I get 2.356. All right, so that would be the answer. That's one petal. Okay, but just to make this even more difficult, or just to talk about other ways to see what's happening, if I plug in theta 0, I get this radius here. Then I plugged in, and I'm going to get, as theta approaches pi over 6, I get all those radiuses. At pi over 6, I get 0. And then this is one of the first ones we graphed last set of notes. What happens after this is it starts to go this way. So if I graphed or plugged in pi over 4, that'd be 3 cosine of 3 times pi over 4, which is equal to, cosine of 3 pi over 4 is negative root 2 over 2. Negative root 2 over 2 times 3 is like some negative number over here. So I get this. When is it here? When is it at 3? I'm thinking that's going to be pi over 2. So 3 cosine of pi over 2 times 3 would be 3 pi over 2. Cosine of 3 pi over 2... is 0. Okay, so this would be 0. So at 3 pi over 2, it's back to 0. So when is it 3 there? Maybe when cosine is pi. 3 cosine, no, that's not right. All right, let's just do this way. Set the radius equal to 3. When is that 3? So cosine of 3 theta is equal to 1. So cosine is equal to 1 when we have theta 0. And then when we have, it goes all the way back around to 2 pi. So divide that by theta. So when theta is equal to 2 pi over 3, so 2 pi over 3, it's like 120 degrees. I would get an, doesn't seem right either. So it goes here, 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 here. When was it there? Was it -3? Oh, I want to know, isn't it -3? So make it -3, negative. When is cosine -1? When pi, or then theta is equal to pi. So when it's pi over 3. So when I have that pi over 3, it's going to be back here at 0. All right, so let me redraw this part again. So this is the way that I think no one's going to do it, but they're just talking about it just in case. So it's equal to, so if I want to draw this and find out, if I wanted to integrate from 0 to pi over 6, I get that red one. Then from pi over 6 to pi over 3, I would get this. So I could integrate from from 0 to pi over 3 of, and then 1/2, and then my radius, the 3 cosine of 3 theta squared d theta, and get the same thing. Okay, that's using the symmetry and all those ideas, but I think there's easier ways to do that. So hopefully you stopped watching after the first one, after I did it this way, and you're just okay with that. But hopefully it helped. Hopefully it wasn't too confusing. But thank you for watching this video, and I sure hope it helped. Bye.